Right. Welcome to our new topic. We're talking about trigonometry today. We'll start talking about trigonometry. Now, when we hear the word trigonometry, if we look at the prefix of the word trigonometry, T-R-I, tri, when we hear about tri, it means it deals with tree. It deals with tree. Tricycle. Tricycle has 3 wheels. Alright? So when it see that word tri, that prefix tri, anything to do with tri, it deals with tree. And geometry means the measurement of lengths and angles. So which shape in mathematics has 3 sides? Yes, the triangle. So what trigonometry is all about is finding the lengths and the angles and things based on the triangle. And today we will start by talking about Pythagoras' theorem. Pythagoras' theorem. Now Pythagoras was a mathematician who came up or who calculated the lengths of a triangle and a right angle triangle. So when we hear about Pythagoras theorem, it is dealing with a right angle triangle. Now, what he noticed that the longest side on a right angle triangle, which is known as the hypotenuse, the longest side on the right angle triangle known as the hypotenuse, when he squared the 2 opposite sides, the sum of the square of the 2 other sides, side A and side B, when he squared these sides and found the sum of them, it always equal to the square of the hypotenuse. Now, from this observation, from this calculation, we can be able to manipulate it to find the length of the hypotenuse or the length of either side if the hypotenuse is known. So, how would we find the length of the hypotenuse? Now, what I want us to remember too, that the hypotenuse, remember it's a right angle triangle, is the side always opposite to the 90 degree, right? It's a 90 degree. Now, the 90 degree, because that is the largest side, these 2 sides will not be cannot be more than 90 degrees. Alright, so these 2 sides will be 2 acute angles. Right, this angle here and this angle here, those 2 angles will always add up to 90 degrees. So how do we find the length of the hypotenuse if we know the length of the 2 other sides? Now remember the formula is a squared plus b squared is equal to c squared. The sum of the squares of these 2 sides is equal to the square of the hypotenuse. So if we want to find the hypotenuse, what we need to do is just find the square root of c, right? Or of c squared. So c will be equal to the square root of a squared plus b squared. And we can use that formula to find the hypotenuse of a right angle triangle. But what if we wanted to find one of the other 2 sides? Let's say we wanted to find the side A. How would we go about doing that? Now, let's go back to our formula. Let's rewrite that formula. A squared plus b squared is equal to c squared. How would we find what A is equal to? Now, let us use our knowledge from transposition and find out how that will be. So we take over our b squared. So A squared is equal to c squared minus b squared. So to find for A, we find the square root of c squared minus b squared. So A will be equal to the square root of c squared minus b squared. And if we want to find for b, same thing we do. B squared will be equal to c squared minus a squared. So b is equal to the square root of c squared minus a squared. So I want us to notice these three formulas. We can make note of them. First one, c is equal to a squared plus b squared. A is equal to c squared minus the square root of c squared minus b squared, and b is equal to the square root of c squared minus a squared. And we are able to find the lengths of any side of a right angle triangle. So let's do an example. Let's start by finding the length of the hypotenuse. So if we're given a triangle, (3 cm, 4 cm, and we want to find the length of the hypotenuse. How do we go about doing that? Again, we apply Pythagoras' theorem. Now, remember, Pythagoras' theorem says that a squared plus b squared is equal to c squared. So that means 3 squared plus 4 squared is equal to c squared. So to find what c is, we can use this, or we must use this. So that will be 9 plus 16 is equal to c squared. So that's 25 is equal to c squared. So c is the square root of 25. cm. So in this case, the length of our triangle, or the length of the hypotenuse, is 5 cm. Now, in cases where all the sides are whole numbers or exact integers, here we have 3 cm, 4 cm, and 5 cm. All the sides are whole numbers. In cases like this, this triangle is known as a Pythagorean triple. Let's just write that word there. Pythagorean triple. Right? Where all the sides are whole numbers. Now this will not happen in every case, but when it happens, all three sides are whole number, it is known as a Pythagorean triple. And if I want another Pythagorean triple, all I have to do is choose a whole number and multiply each number here by that whole number. So another Pythagorean triple, let's say we choose 2. 2 3s will give us 6 cm. 2 4s will give us 8 cm. 2 5s will give us 10 cm. So if this represents the sides of a right angle triangle, whose one side will be 6, the other side will be 8, and its hypotenuse will be 10. So let's try another one. And what you could do is you could check to see. Let's check to see this. 6 squared plus 8 squared. Let's see if it's equal to 10 squared. We know that 10 squared is 100. 6 squared is 36. Plus 8 squared is 64. That will give us 100 there. So what we notice, this is will be a right angle triangle whose hypotenuse will be 10. So let's try another where we're finding the hypotenuse. Let's say we have 7 cm and 10 cm, and we want to find the value for x. And what you could do is pause the video and try to see if you can get the answer. Alright? Here is our right angle. So let's work it and see if you have the same answer. So remember, we said that using Pythagoras' theorem, that 7 squared plus 10 squared is equal to x squared. 7 squared will give us 49. 10 squared will give us 100 and will be equal to x squared. That's the length of the hypotenuse. So 149 is equal to x squared. So now all we must do is find the square root of 149 to get our answer. So the square root of 149 is 12.21 to 2 decimal places. Alright? 12.21 to 2 decimal places. And so it is. This will be our value of the length of the hypotenuse. In our next video, we will see how to find the length of one of the sides when the hypotenuse is given.